This was our patch. Kevin Chilton was in charge of making sure it all got approved. Most of the design was actually from Tom Jones. This is us while we're on orbit. You can tell that we're having a good time. This was our crew press conference while we were up there. And just gives you another chance to see all of us up in space. This was the morning we actually launched. We're headed out to the pad. We went out twice and launched on the second attempt. So we were happy to do that. It turned out that the weather wasn't that great after we launched, so if we hadn't gotten off that day, we'd have been waiting around for some time. The vehicle really feels great when those main engines finally start. They run for about 7 seconds or so, and we launched right at the crack of dawn. So as you can see here, I know some of you were down there for the launch. It had to be absolutely beautiful. The only better view was in the rearview mirror. That was the view we had as we were headed up there. And we've got a number of launch pictures here just because I think it was an incredible launch. You can see we're arcing up toward the north, heading into a 57-degree orbit. It was a beautiful, crisp morning, so they were able to track us for a long range. So we've got a lot of good launch video here. And it feels like you're awfully small out on the end of this giant explosion, which is exactly what it looks like here. You'll see the SRBs come off, and then you'll see a shot from the orbiter itself as the SRBs come off. And then you can see it was so clear that morning that they've got some good shots here of the SRBs falling away or floating away. And the main engines continued to burn. Our children told us we looked like a star going over the horizon. And really felt great to get into orbit that day. Here's the external tank separation. We don't see this real time, and that's probably good that you don't see all those things floating around. Might make you just a little bit nervous, but that's all basically ice and things like that floating around. It's not really a problem. And the next shot is one Jay took after we rotated the vehicle to get some footage of the external tank, and Linda was shooting some 35-millimeter shots at this time to get data on the tank.
Now we're on orbit. This is the sunrise, and as the sun comes up, it's just a beautiful view of seeing the tail of the orbiter come into view, and then our payload in the payload bay. You can see the large antenna structure, the JPL project and the German and Italian space agencies, a large antenna. And in the foreground, where you can't see it, is the platform for the sensor from the Langley Research Center. In the forward flight deck, Sid's busy here putting in one of the 412 maneuvers that we did during the mission. Basically, we wait for one maneuver to time out and then enter in the next one. Those allowed us to do some yaw steering to help the radar ambiguities. Another major thing we performed during the mission were all the tape changes, and Tom's doing one here. We did, I think, 163 tape changes on time during the mission. That's where all the radar data was recorded, and we had 2 recorders on the left side of the aft flight deck where Tom is working here, and another one on the other side for 3 total. The aft flight deck was where the action was on this mission, there's no doubt about it, and we had some extra panel covers made with Velcro squares on them. You can see them in the back, and basically it held all of our cameras and lenses, and Sid was using the Linhof, and Chili's just surrounded by Hasselblad camera bodies and a spot meter or 2 and ready to go to work. This is our Linhof film changing bag. I did it a couple of times during the mission. We had to change out our Linhof film, and once your hands are in there, you can't come out till you're done. And there's you've got exposed film in there, a new film, and the roll you're trying to work it into, and finally success. I think Jay did most of our film changing during the mission. Briefly, a nice view from one of the aft cameras showing the payload and our aft windows.
The aft flight deck was really where we did all of our work on the daylight passes. We were doing a lot of photography in support of the radar observations. On the left there, you see the Linhof camera mounted to a bracket on window number 7, and you could tilt that to line it up with the radar bore sight. And then Rich here is working with the 40-millimeter lens out the window, and we had a lot of handheld shots of the targets of interest to the radar and the maps folks. This is a sweeping pass coming southeast across the California coastline, north of San Francisco, across the approaches to the Sierra Nevada, and very soon you're going to see some landmarks out here that you'll recognize from your geography lessons. The Sierra Nevada is the snow-capped range here. You come into view of Pyramid Lake right here, and then Lake Tahoe coming into view at the bottom of the screen. And as we walked down the Sierra Nevada, we saw our super site for hydrology at Mammoth Mountain, right next to Mono Lake here. This is where Mammoth Mountain is. And then if you follow the Owens Valley down the front of the Sierra Nevada, you'll come to Owens Dry Lake, right down at the bottom here, stepping across to Panamint Valley, and then Death Valley. And here you see Cotton Ball Basin and the Badwater, the lowest point in North America, at some 200 feet below sea level. This is a Jet Propulsion Lab graphic showing our radar imagery collected on the mission laid onto a topographic map of Death Valley. This is the northern end of the valley and Cotton Ball Basin, and as you fly through this virtual reality presentation north out of Death Valley, we sweep around the northern end of the Panamint Range, and this is the Stovepipe Wells target in Death Valley that we imaged many times on the mission, and we studied the interaction of the surface there with the radar roughness measurements. Now you can look back south down Death Valley to Cotton Ball Basin and Badwater, and these are the Panamint Ranges and the Black Mountains on the left. Here on the aft flight deck again, you see Jay using the 90 millimeter Linhof camera. So we had two big lenses out the back window to document the radar sweep across the Earth. And I'm using the spot meter here to get the right exposure level for all of the cameras we're using on the aft flight deck. This is Siberia. It's so bright with this snow cover that you actually have to use sunglasses to get a good look at the surface down there. And we saw the Trans-Siberian Railway region many times in the first third of the mission as the top of our orbit took us over at Siberia. We had a lot of ecological and geological targets in that region. Now we have a picture here of Jay and Rich conducting one of the many maneuvers on the flight to point the radar accurately. And as they entered the maneuver into the orbiter computers, then the orbiter did a slow walk during our passes to point the radar just so. This is the Sahara Desert region. We had a lot of investigations here to use the radar to penetrate below the dry sand in the Sahara to look at the bedrock below. And the drainages revealed by penetrating the sand sheet here show us how those drainages were formed and what the past climate of the Sahara was like.
Here's our payload commander, Linda Godwin, on the aft flight deck, getting ready for a pass down over the Ukraine and the Caspian Sea. Here you see the many farms in the Ukraine, beautiful area from out there, getting down to the area near the oil fields at the top of the Caspian Sea. And here's a beautiful geological feature there, going out to the Caspian, which is a very interesting feature studied by a lot of the scientists here at Johnson Space Center. The level of the Caspian Sea has changed greatly, and by studying features like the seacoast here, the folks here can tell how high the sea level has gone or how low it's gone. It actually has gone up about 2 meters in the last few months, about 6 feet. You can imagine what that would do to us here in Houston. You see the roads and so forth down there. Here's a beautiful picture of the radar and the payload bay showing everything out there. And here's the redshift. Wearing blue shirts on
You were wearing red shirt.
Oh, that's right. On the flight deck, and you can see just how busy it was getting ready for one of these data passes. Overlaid here with on the outside is our TV cameras out in the payload bay, and on the inside, that little square is the radar. So you can see how much more is revealed by the radar. These white blobs that you see turning into black in the radar area are frozen lakes in Canada. We were talking to some of those people on frozen lakes down here on the Shuttle Amateur Radio Experiment. Built by folks at Motorola and here at Johnson Space Center. And we loved talking to people on the ground with that. It really made us feel connected with them. We talked to students in 9 schools throughout the world. That's not all we did up there with the schools. We spent a lot of time on educational activities up there, both live downlinks that some of you may have seen, and making an educational film on geography, which we hope will be released for students in schools here real soon.
It's shift handover, and Sid's kicked the blue shift down to the middeck, and that's what you see us doing. Tom coming down, and I'm shortly followed by myself here. We're coming down to the middeck to do some of the orbiter activities associated with maintaining the spacecraft in good condition. You're going to see a shot of TJ here working out on the ergometer. Right behind Tom, over his left shoulder, is our rowing machine, which we also carried up there. Some people use the rower, some people use the ergometer. For longer flights, these things are almost critical to the operation. And the infamous galley is just above the rower there, where we had some problems. This was an experiment of moving a rigid body in space, getting ready for the sleep shift. It's sped up a little bit. It's 2 to 1. A little bit. It's 2 to 1 in time. Then we had to slow the film down to show it to you. But the sleep stations were really handy. We had a good time with them. We used a 4-tier sleep station. The bottom tier was used for strictly stowage, and we did hot bunk. But the sleep stations really provided good, quiet, and light tide area for us to get a restful 6 to 8 hours of sleep during each period. You're going to follow this with some more orbiter activities, mainly some meal operations and some cleaning, and you'll see the crew doing different operations and how we maintain good hygiene in space. This is Chili trying to show off his body.
A mistake.
What a mistake. But it's interesting to take a sponge bath up there, which is, of course, the way we had to do it. You just use the hygiene hose and put some liquid soap on the rag along with some water and wash off your body, especially needed after an exercise period. A quick view of some of the food operations. Behind the crew on the forward flight deck lockers are 3 food trays, which you can see are in use right now. They were useful for stowage. This is a water dump, a unique view of that. Chile has set up the water dump looking out the pilot's window number 1 and then giving you a close-up view of how it forms the ice particles immediately on expulsion into space. And following this, we're going to have some other experiments with space science here. This is seeing how a gyroscope works in space. These are our gyro-stabilized binoculars, and what I've done is I've just turned them on, and you can see how they try to maintain a position in space. These were particularly useful for looking at some of the Earth observation sites for close-up views. Now we're over to Chile.
Well, you'd think someone who'd flown before would know how to eat cashews in space, but of course, I got a little help there.
She does.
Got a lot of help, I should say. You got to enjoy yourself while you're up there in the little free time that you have between, in particular when you got the whole shift or both shifts together. And Tom found a unique way to use the TIPS paper roll. When the roll was out, he turned it into a blowgun for shooting malted milk balls across the cockpit there. I think Jay was declared the champ here, the only one that could successfully grab one. Rich had done an experiment with fluids on his previous flight, and so he convinced us that we needed to do a little experiment on this flight. And this is always a good thing to show the school children how fluids behave floating free in gravity, and to demonstrate to them that this is not, in fact, a bubble, but a solid sphere of liquid. And Rick demonstrates that here as it wicks away onto the towel just before it hits the overhead window. This is the entry into, or the beginning of my favorite part of the flight, which is entry. And here we are on FCS checkout day, the day before our first attempt to come home. We didn't have many payloads that moved on this, so we had to throw the Elevon in here coming up during FCS checkout. The radar is pretty static back there in the aft. But entry was pretty fantastic. And, of course, there's always a little bit of regret with your final view of the last sunset on orbit before you come home. But as the sun sets on Endeavour here, we come back to a spectacular sequence here that Tom Jones shot. Carrying the camcorder in the back seat during entry, here you can see over Sid's shoulder in the front, the orange glow out the front. And now Tom zooms in on his mirror to look out the overhead window, and here's the wake of the orbiter during entry. And so you can see the hot plasma forming a plume of fire behind the orbiter. Out Sid's window, it's still hot and glowing. Out my window, you can see that we've gone into daylight. And in this tremendous right turn that we made for the majority of reentry around the Crater Lake and Mount Shasta and Mount Lassen in California and on down the San Joaquin Valley, it was just a tremendous reentry view as we came down the whole length of the state of California. Sid did a beautiful job rolling us onto the hack and flew right on the money all the way around here. You see him rolling out on final on the outer glide slope. Tom's still holding this 500-pound camera now. Looking out over my right shoulder, you can see the ramp there at Edwards Air Force Base. And Tom was a real trooper carrying that thing all the way down through landing here, having it ready to film a few sequences here. An absolutely beautiful day to land at Edwards Air Force Base, and Sid made an equally beautiful touchdown, nice and smooth. On the hard runway there, runway 22, we were constrained because of our weight and CG to land on a hard surface runway. So we had no choice other than Kennedy and Edwards 22 for coming home this day, and we were happy to come home after waving off the first opportunity. The drag chute worked as advertised, and rollout was great. Again, Tom looking over my right shoulder here as we jettison the drag chute, rolling out on the runway at Edwards Air Force Base to wheel stop. And I think after wheel stop, it's kind of a bittersweet moment for the whole crew. You're certainly happy and pleased to be back home. You hate to see the mission end, but one more time around the cockpit here, congratulations for Sid for a wonderful landing, and a happy flight deck crew, and no longer a rookie Tom Jones getting ready for his next flight.